which says, theorem number 2, that every square matrix A can be expressed as sum of symmetric and skew symmetric matrix, that is half of A plus A transpose plus half of A minus A transpose. As we want to cover the concept, proof is not required for this. Just now we have learned that A plus A transpose symmetric. Even if I multiply by half, this will give us symmetric matrix. Symmetric matrix, whereas this part will be skew symmetric matrix. And you can just see, if you just simplify, half is common here, then A transpose minus A term will get cancelled, and A plus A will be 2A. 2A by half will be A itself. So every square matrix can be expressed as sum of symmetric and skew symmetric matrix. On this we are going to have 3 marks problem. Now let us move on to the next concept, that is invertible matrices. Now what is this invertible matrices? A square matrix A is said to be an invertible matrix if there exists a matrix B such that product of AB and BA should give us I. It's same like in a real number system. If I have 7, what should I multiply here to get back 1? It is 1 by 7. Similarly, 1 by 7 into 7 will be 1. And we denote this B as A inverse. So just in place of B, we write inverse of A. So B is inverse of A, and both A and B are square matrices. So this will be the definition for invertible matrix. About now invertible matrix definition, let us move on to the 2 important theorem on this. The first theorem, that is theorem number 3, as per the NCERT textbook order. Okay. If inverse of a square matrix exists, then it is unique. Nothing but we cannot have more than one inverse for a given square matrix. So inverse uniqueness, we can say this, inverse uniqueness. Now let us try to prove this theorem. Coming to the proof of this, so first the matrix should be a square matrix. So let A be a square matrix of order n by n. Then we have to prove the inverse is unique. So suppose we go by method of let us suppose that there are 2 matrices and both are inverse of A. So suppose B and C are inverse of matrix A. Now I have to prove that B is equal to C. Now since B is inverse of A, the definition of invertible matrix says A into B is equal to B into A is equal to identity. Now since C is also inverse of A, so I should have A into C is equal to C into A is equal to I. Now I have to prove what B is equal to C. So let's consider B. As we know, for matrix B I can also write as B into I, because when I multiply any matrix B with identity, I get back B itself. Now from equation number 1 and 2, see carefully, I can write I as A into C. This I is A into C, and by using associative property I can write this one as B A into C. So I got this one from equation number 2. Then BA. What is BA? It's again I from equation number 1. But what is I into C? When I multiply any matrix by identity, I get back C. So I have proved that B is equal to C. So if at all inverse exists, it will be unique. Now let us try to go for one more theorem. The last theorem here, which says that if at all A and B are two square matrices and if they are invertible, then we have to prove that A into B, the whole inverse, is equal to B inverse into A inverse, provided both are invertible matrices. So for this, the proof will just go like this. So if A and B are invertible matrices, if so, obeying this one, so AB and AB inverse should be same as AB inverse into AB should be equal to identity. I have just used the definition. If at all I have got invertible matrices, we know that A into A inverse should be equal to A inverse into A should be equal to I. So in place of A we have AB, in place of A inverse we have AB the whole inverse. Again the same thing here. Now let us consider the first and the last. So when I'm going to consider here AB, then AB the whole inverse is equal to I. Now here we have A. See, I want to prove this. I have to prove this. To prove this, see, there is no matrices here. Now how to get this insurance that what we have to know how to solve the problem. Here we don't have any matrix, but here the left of AB the whole inverse we have got A and B. I have to remove this. So how to remove? Since I have got here A, I am going to pre-multiply A inverse on both the sides. Pre means before the matrix, post means after the matrix. So since I want to multiply before the matrix, so just pre-multiply. So A inverse into A, then B, then AB the whole inverse is equal to A inverse into I. So this, what is A inverse into A? It is I. So I can write this one as I, then into B, then AB the whole inverse. And again we know that whenever you multiply any matrix A with identity, you get back matrix A, same as here I into A. So A into I is A, so A inverse into I will be A inverse itself. Next, I into B. Whenever you multiply any matrix with I, you get by the same matrix, so I into B will be B. Then AB the whole inverse is equal to A inverse. Now I have got B. I want to remove B. How to remove B? Pre-multiply B inverse on both the sides. So what will you get? B inverse into B, AB the whole inverse is equal to B inverse into A inverse. Again, what is B inverse into B? From this it is I itself. So I times of AB the whole inverse. So B inverse into A inverse. Whenever we multiply any identity matrix with A, I get back the same matrix here. So this will be AB the whole inverse is equal to B inverse into A inverse. And hence we have proved the result. So with this we have finished all the concept. I just want to take one example to make you understand that when we say invertible, how is that A into B will be identity. One example I will take. So one example here, one question. So let us suppose that A is a matrix 1, 2, 3, 1, 2, 3 and here 5. Then I am taking one more matrix B. That matrix is this. Now I am just trying to give an example about invertible matrices. When do we say a matrix is inverse of each other? Okay. So for that, as we know that when I multiply the two matrices, we should get back identity. So let us multiply, and if this product is giving identity, then we say B as inverse of A, and A is inverse of B and B is inverse of A, both the ways. So A into B. So if I perform multiplication, multiply it, first row, first column, 1 5s are 5 minus 6 for a while. Have I taken a proper example for a while? Oh, okay, I have to have a sign like this. Okay, now we can go ahead. Now it is multiply. 1 into minus 5 is minus 5, 2 into plus 3 is 6, 1 into 2 is 2, 2 into minus 2 is minus 2, sorry, 2 into minus 1 is minus 2, then 3 into minus 5 is minus 15, then plus 15, then 6 minus 5. So answer of this will be 1 0 0 1. This is the identity matrix. Now let us also take B into, what is B here? Minus 5 2 3 minus 1. And what is matrix A? 1 2 3 5. So now let us multiply this row versus column. So I'll get minus 5 plus 6, then minus 5 2s are 10 plus 10, then 3 into 1 is 3 here, then minus 3, 6 minus 5. So we are going to have this one to be 1 0 0 1. Yes, again I have identity matrix. So you can see that A into B, this A product is I, and I is also same as B into A. That's what we call invertible matrices, and you will not find any other matrix other than B for A to satisfy this condition, similarly other than A to satisfy for B. So both are inverse of each other. So with this we have completed all the concepts of matrices. Now in the next video we are going to take up the problems on model question paper, which is issued by Karnataka School Examination and Assessment Board. As I promised that after we complete matrices concept, we are going to take model question paper, which is issued by Karnataka School Examination and Assessment Board. So we have got 3 model paper. In place of solving model paper as per the order which is given by the board, I thought we'll take a chapter, complete the concept, and then we'll take all the problems from the model paper chapter wise. So with that, we are ready with the first problem. So if we just see the model paper, from part A we are getting 1 marker question, part C we are getting 1 3 marker question, and part D we are getting 1 5 marker question. So 1 plus 3 plus 5, totally 9 marks we are getting from this chapter. And in all the model paper, same thing is followed. So now first we will complete first model paper. Now the question, the 1 marker question says the product of matrices A and B is equal to a diagonal matrix. So they are talking about multiplication of 2 matrices here, A and B, and they are saying that if at all we are going to multiply A and B, we are getting a diagonal matrix, suppose D. Then if the order of the matrix B is, so the order of the matrix B is 2 cross 3, then they want us to find what is the order of the matrix A. So let us assume for a while the order of the matrix A is M by N. We have to find what is the order of the matrix A. So let us write it here. Now first thing, since the product should be a diagonal matrix, we know diagonal matrix is which matrix? Square matrix. Okay. Now this entire problem is on product of 2 matrices concept. Product of 2 matrices exists provided first matrix number of column and second matrix number of row both should be same. So from this one thing is clear that n should be equal to 2, only then matrix multiplication is defined. And after we multiply 2 matrices, the obtained matrix D order will be m by 3, nothing but number of row of the first matrix and number of column of the second matrix, that is m cross 3. Now since it should be a square matrix, value of m should be equal to how much? 3. Therefore, I can say the order of the matrix A is m value is 3 and n value is 2. So the order of the matrix A is 3 by 2. 3 by 2 is there in option C. So option C is correct for problem number 3. We have to go for this question. So it's a 3-marker question. Let us try to solve this. See, coming to this, we have discussed one concept that every square matrix A can be expressed as sum of symmetric and skew symmetric matrix by using this formula. A is equal to half plus A transpose plus half of A minus A transpose. So since part C it is, so it's a 3-marker question. Now matrix A is given in the question. We have to find the transpose, and after finding that we are going to find A plus A transpose divided by 2, A minus A transpose divided by 2, and then we are going to substitute here. So after we substitute and simplify, you should get back A. So let us go one by one. First I will find A transpose. So how to find A transpose? We have to change this row 1 4 to column, and this row 6 7 to a column, second column. Now I have to perform addition. So A plus A transpose. You can see one thing, that my each step is depending on this formula there. So A plus A transpose. So what is matrix A? Here it is 1 4 6 7, and A transpose is 1 6 4 7. Now we know how to add. We have to add corresponding element. So first with first. So here 1 plus 1 will be 2. Then 4 plus 6 will be 10. 6 plus 4 will be again 10. 7 plus 7 will be 14. And as per the formula, we can see we have got half here. So let us divide by 2. When I divide by 2 on both the side, I mean to say I have to take this one and the extreme right part. So when I'm going to divide by 2, I'll get half of A plus A transpose, which is equal to, let us go step by step. So I'll get 2 here, 10, then 10, and then 14. Now it's a scalar multiplication. Take half in and divide each term by 2. Then I will get this one to be 2 by 2 will be 1, 10 by 2 will be 5, 10 by 2 will be again 5, 14 by 2 will be 7. So I came to know that half of A plus A transpose value is this matrix 1 5 5 7. This I will regard as equation number 2. So now I have to find A minus A transpose. Let us continue. Now I want A minus A transpose. So moving on to A minus A transpose. Coming to matrix A, we have 1 4 6 7, and already we know A transpose, which is here, minus sign because of this, and 1 6 4 7. Again I am stressing that this formula we have seen in our concept matrices, and you can just see here also how to get this, and how can we justify that this is equal to matrix A. Half we can take common out, then A transpose minus A transpose will get cancelled. A plus A will be 2A, 2A by 2 will be A itself. And now it is performed. Now here we are also learning subtraction of two matrices. Let us write this one as it is. As I said in my introduction video, that I have seen many students getting problem of stuck when they are subtracting. So I suggest first you multiply minus to each and every term, that is minus 1. So I will write plus here, and I will take negative in. Minus to plus is minus. Minus to plus is minus 6 here. Minus to plus is minus 4. Minus to plus is minus 7. So I have just basically performed school days multiplication of sign. Minus to minus is plus. Plus into minus is minus. Minus into plus is minus. And plus into plus is plus. Signal the multiplication of sign. Now when you are going to subtract or add, remember the rule. We are going to add any two real numbers if signs are same. I repeat, signs are same. And we are going to subtract if signs are different. And after adding or subtracting, depending on this criteria, the largest number sign we are going to assign. Okay, for example, let us suppose that we have 3 plus 7. Since signs are same, I am going to add. So 3 plus 7 is 10. Largest number is plus. The largest number is 7 here. A sign is plus, so plus here. Similarly, if I take 3 minus 7, signs are different. So I am going to subtract. 3 minus 7 is 4. And in this, which is larger number, 3 or 7? 7. What sign here? Minus. So please understand, many students have a confusion. No, they will come here and they will say plus into minus is minus or minus. No. This is multiplication of sign. Whereas to give the sign for the number, it depends on which number is larger and the largest number sign is assigned. Okay, now see one more. So minus 3 plus 7. So again signs are different, so I have to subtract. So what I will get? Minus 3 plus 7 is 4. Who is the largest number? 7. Sign is plus. So you can see that we are nowhere using this rule. This is only for when we want to multiply both the numbers. Similarly, what is minus 3 minus 7? Signs are same. We can add. I will get 3 plus 7, 10. In this largest number is 7. So minus sign assigned. So this is what going to happen. Now let us move on. So how to subtract two matrices or add two matrices? Corresponding element 1 minus 1. Signs are different. So it will be 0. For 0 there is no need to give any sign. 4 minus 6. Signs are different. So 4 minus 6 is 2. And largest number is 6. So I can write minus here. Then 4 minus 6. Signs are different. I have to subtract. 4 minus 6 is 2. And the largest number is 6. So plus is assigned. 7 minus 7 is 0. So we have got A minus A transpose. As the formula says, we want half also. So we are going to divide by 2 on both the sides. Now we will get half of A minus A transpose. Then when I divide by 2, let us show the steps. Now when I am going to divide, 0 by 2 is 0. Minus 2 by 2 is minus 1. 2 by 2 is 1. 0 by 2 is 0. So we got half of A minus A transpose. So we have got the other result. This is my equation number 3. So we have to prove that this matrix can be expressed as sum of symmetric and skew symmetric. We have found the symmetric part as well as skew symmetric part. Let us put both this equation number 2 and 3 back in 1, and on simplifying, are we getting matrix C or not? We have to check. So substitute, or I can say put equation number 2 and 3 back in 1. When I do so, in equation number 1, I am going to put here this part of the right hand side. So half plus A transpose is this, that is 1557, then plus, then half of A minus A transpose is here, that is 0 minus 1 1 0. Now simplify, we know how to add two matrices corresponding element. So 1 plus 0 is 1, 5 minus 1 is 4, 5 plus 1 is 6, 7 plus 0 is 7. Now let us check, have we got the same matrix? Let us write properly this 7. Have we got the same matrix? 1 4 6 7. Yes, 1 4 6 7. Yes, we have expressed that sum of symmetric and skew symmetric will be the given matrix itself. So with this our problem completes. The marks allotment will be this, till here 1 mark and then till here 1 mark, and showing sum of these two will be the given matrix itself will be 1 mark, totally 3 marks. Very carefully, whatever we want to verify, this is one of the property, that is distributive property when we discuss matrix multiplication. And what I just want to comment now, if it is a CET question, no, as soon I will see if A plus B and A plus B into C is defined, AC is defined, BC defined, nothing but addition of matrix and multiplication is defined, there is no need to say verify. As soon as it is defined, surely this should be true. Okay, but since it's a 5 marker question, we have to verify and show that it is true. And I'm using the word show that because as soon order is for addition and multiplication condition is satisfied, surely it will be true only, because it's a property. It will be true for all the matrix as soon it is defined. Now let us go one by one. First they want AC. So we are going to learn matrix multiplication again. A is here. So the elements 0, 6, 7, minus 6, 0, 8, then 7, minus 8, 0. Coming to matrix C, it is here 2, minus 2, 3. Don't forget the sign. Again I am repeating, what is plus into plus, plus, minus into plus, minus, plus into minus, minus, minus into minus will be plus. The matrix multiplication sign. Now recall how we are going to multiply two matrices. We have to multiply a row by its column, and we have to multiply corresponding first with first, second with second, third with third. So here this is the first element of the row and first element of the column. 0 into 2 is 0. Then plus this one, plus into minus is minus. 6 into 2 will be minus 12. Then plus into plus is plus. 7 into 3, 21. Corresponding element we have multiplied. No more column, so we have closed the bracket. Now we come to second row. So this row I have to multiply to the first column. Minus 6 into 2 will be minus 12. 0 into minus 2 will be minus 0 because plus into minus is minus. Then 8 into 3, corresponding element, 8 into 3 will be 24 with plus sign. Why plus sign? Plus into plus is plus. Where you should remember the multiplication sign. Now comes to the third row. Plus into plus is plus. 7 into 2 will be 14. So we know that whenever we won't mention the sign, it is understood it is positive for non-zero number. Minus into plus is, minus into minus will be plus. 8 2s are 16. 0 into plus 3 will be 0. Now let us try to get the solution of this. What will be matrix AC? Simplifying. 0 minus 12 and plus 21 will be 9. Minus 12 plus 24 will be 12. 14 plus 16 plus 0 will be 30. So we have got the value of matrix AC. Now I want matrix BC. Okay, let us take matrix BC. What is matrix B? 0 1 1, 1 0 2 and 1 2 0. Coming to matrix C, it is 2 minus 2 3. Now let us try to multiply these two matrices. When I want to multiply these two matrices, again the same thing, we have to go row by column. So the first row in this matrix, as you can see, it is 0 1 1 and the column is this. So when I am going to multiply, see carefully, 0 into 2, the first element, 0 into 2 is 0. 1 into minus 2 will be minus 2. 1 into 3 will be plus 3. As soon as we have finished the column, I have just closed the bracket. Now we go to the second row from here. 1 into 2 will be 2. 0 into minus 2 will be minus 0. 2 into 3 will be plus 6. Next, coming to the third row, again corresponding element, 1 into 2 will be 2. Plus 2 into minus 2 will be minus 4. 0 into plus 3 will be 0. Now let us simplify. So the matrix BC, we are going to get 0 minus 2 plus 3 will be plus 1. Because here 3 minus 2 is 1 and the largest sign is 3, sign is plus, so I write plus. Again you see 2 minus 0 plus 6, so 6 plus 2 will be 8 and both are positive. Anyway, 6 is the largest number, sign is plus, so plus only. Here 2 minus 4 plus 0, signs are different for 2 and 4, so we have to subtract. 2 minus 4 will be 2. Who is the largest among 2 and 4? 4. What's the sign of that? Minus. So I can write minus sign here. To be still specific, if you just see the order of matrix A, it is 3 by 3, and for matrix C, it is 3 by 1. So we know for matrix multiplication, column of the first matrix and row of the second matrix should be same, due to which multiplication exists, and obtained answer should be of this order 3 cross 1. That's what you can see, 3 rows and 1 column, that we can see again. Similarly, same thing here also, this is 3 by 3 and this is 3 by 1. So the obtained matrix should be of order 3 by 1. Okay, now let us move on to A plus B into C. First I have to find what is A plus B, then we can go ahead for the remaining. Now we are going to relearn how to add two matrices. Matrix A, here it is, so it is 0 6 7 minus 6 0 8 7 minus 8 0 plus what is matrix B? Here it is, let's write this one, 0 1 1, then 1 0 2, lastly 1 2 0. Now how to add these two matrices? Corresponding element we have to add, and for addition order should be same. As you can see, 3 cross 3, 3 cross 3, number of rows of both the matrix and the columns are same. So now when I want to add, just see, 0 plus 0 will be 0, 6 plus 1 is 7, 7 plus 1 will be 8. Next, minus 6 plus 1. Signs are different, so I have to subtract. 6 and 1, if I subtract, you get 5. The largest number is 6, so it will be minus sign here because 6 is the largest number. Then 0 plus 0 is 0. 8 plus 2 is 10. And the largest number is 8, so plus sign will be allotted. Next, 7 plus 1 will be 8. Minus 8 plus 2 will be minus 6. 0 plus 0 is 0. We got A plus B as well. Now again see, A plus B into C I want. Perform A plus B and multiply with the matrix C. Already A plus B have performed. So it is 0, 7, 8, minus 5, 0, 10, 8, minus 6, 0. Now coming to matrix C. What is matrix C? Here it is 2, minus 2, 3. Now we have to just perform what? Matrix multiplication. Now again recall how to do it, row versus column. So just see here, this first row should be multiplied to first column and we have to multiply the corresponding elements. So when I'm talking about the corresponding elements, I mean to say in this row first element is this, in this column first element this. So 0 into 2 will be 0. Then second element with this second element, 7 into minus 2 will be minus 14 because plus into minus is minus. Then plus into plus, third element with third will be plus. 8 3s are 24. Now comes the second row, minus 5 into 2 will be minus 10. 0 into minus 2 is minus 0. 10 into 3 will be plus 30. Then third row with the first column again, 8 into 2 will be 16. Minus 6 into minus will be plus. 6 2s are 12. 0 into 3 will be 0. Now let us perform the simplification and I'm going to add this, simplify this. So 0, okay, no problem. Minus 14 plus 24, signs are different, we have to subtract. So 24 minus 14 will be 10 and in this largest number is 24, sign is plus, so I write plus here. Minus 10 plus 30 will be 20. 30 is the largest number, so again plus 20. Even if I won't write plus, there is no problem because whenever for a non-zero number, if the sign is not specified, it is always what? Positive. So now coming to this, 16 plus 12 will be 28 and again it's positive. So we have got the value for the operation A plus B into C and let us regard this as, okay, this is equation number 2 I will take and this I will take as equation number 3. See, we have completed 3 here. Then we have to verify this part is already done. Now just I have to add AC and BC and I have to check are they equal or not. AC and BC. Okay, fine. Let us consider AC plus BC. What is AC? 9, 12, 30 plus what is BC? 1, 8 and minus 2. A column matrix. Now we should just add them and orders are same. I mean to say this is 3 cross 1. This is also 3 cross 1. So we can surely think of adding. So 9 plus 1 will be 10. 12 plus 8 will be 20. Then 30 minus 2 will be 28. Why plus sign for this? Because 30 is large compared to minus 2. Now this I will regard as equation number 4. Don't forget the left hand side. It is AC plus BC. So we have got the left hand side and right hand side of this. So let us highlight this. So the left hand side here it is and the right hand side is here. So as you can see both the values are same. So we can say that we have verified. So let's write the conclusion. Therefore from equation number 3 and 4 we can conclude that since right hand side is same, it means left also same. So A plus B into C is equal to AC plus BC. Yes. So with this we have completed the problem. The marks allotment will be like this. Calculating AC will be 1 mark, BC 1 mark, then A plus B will be 1 mark, then this 1 mark. Getting this with the conclusion will be finally 1 mark, totally 5 marker. So with this, model paper 1 is completed on chapter matrices. Yes, my dear students, let us move on to the model paper number 2, again on chapter matrices. Coming to model paper number 2, part A, question number 3, which is a 1-marker question. Question says, if the matrix A is given by this is a symmetric matrix, the matrix is symmetric matrix, then the values of A, B respectively are. I request each student kindly go to the concept of matrices. I have already uploaded the video on concept of matrices. In detail we have covered, which in detail matrices is been done within 2 hours video. Okay, so kindly go through. All the concepts are crystal clearly discussed. Okay, then you will have a very good hold on this. Okay, let us move on to this. So if it is a symmetric matrix, we have to find the value of A and B. So let us copy the question, the matrix A here. So the matrix A which is present 0, 2B, minus 2, 3, 1, 3, then 3A, 3, minus 1. Now, since it's a symmetric matrix, already we discussed, for symmetric matrix, this is, as you know, diagonal element. We are not talking anything for diagonal element on symmetric. They may be same, different, please bother. But this corresponding element should be same. Similarly, this corresponding element should be same. As you can see, these two are same. So now just we can equate and try to solve. So here 3 is equal to 2B and 3A is equal to minus 2. So solve for B here. So if I divide by 2, I will get 3 by 2 is equal to 2B by 2. 2 and half will get cancelled. So I will get, therefore B is equal to 3 by 2. Whereas here I have to solve for A. So divide by 3. So we are going to have 3A by 3 is equal to minus 2 by 3. 3 by 3 get cancelled. A is equal to minus 2 by 3. So very clear, the value of A is minus 2 by 3 and value of B is 3 by 2. When you are taking the option, no, you should be extra careful. What I mean to say is, first they are asking A value, then B value. So it means in the option, in all the option, first entry is option A and second entry is option B. This you should have, no, this common sense logic, because the word respectively is used. So in each option, since respectively is used, first with first, second with second, mean to say A with all this, B with all this. So A is minus 2 by 3 and B is 3 by 2. So option A is correct. See, surely we can have something like that. The same is there in one of the option, but they are interchanged. That time, if it is something like this, let us suppose no, one option is given like this. Then what's the meaning? There's now problem, which one to tick? That's what I'm saying, respectively what is there. So it means in all the option, the first entry is option A and the second entry is, sorry, the first entry is for A and the second entry is for B. Okay, we should be careful. Now in that case, this will be again disregarded. Now let us move on to the next. Prove that for any square matrix A with real entries A plus A transpose is symmetric matrix and A minus A transpose Q symmetric matrix. A 3-marker question. In our matrices concept video, we have discussed this derivation, but let us again redo it, no problem. Coming to the solution or the proof of this, they said A, this matrix A is any square matrix. Okay, so let us take A as Aij, and here I am mentioning M cross M, nothing but it's a square matrix of order M. Now, since it's a square matrix of order M, I have to prove that A plus A transpose is symmetric. So to prove, what we have to prove, A plus A transpose is symmetric matrix. Let us take, so let us consider A plus A transpose. Recall the concept. For a matrix, square matrix to be symmetric, if I take transpose, that is A transpose, I should get back A. If I take for skew symmetric, A transpose should be minus A. So whether it is symmetric or skew symmetric, transpose is mandatory. So I will assume this one as some matrix C. So I will be taking transpose on both the sides. When I do so, C transpose is equal to A plus A transpose the whole. We know the property that A plus B the whole transpose is A transpose plus B transpose. So the transpose will act individually. So this transpose, as you can see here, first this transpose went for A and B separately. Even similarly, this transpose will act on A also and A transpose also. So I am going to get this one as A transpose plus A transpose the whole transpose. And what is A transpose the whole transpose? I will get A itself. So all here we are applying the properties, and we actually want this. First is A, then A transpose, but now here A transpose first, then A. Don't forget from the properties of matrix addition, addition is commutative. A plus B is same as B plus A. So I can change the order. So first I can write A, then I can write A transpose. So this is same as equation number 1, which is present here. So I can just write this the same as matrix C, and what's left hand side? C transpose. So I have got the C, A plus A transpose. When I take transpose, I got back the same. Therefore I can comment that C is equal to A plus A transpose is symmetric matrix. Now let us move on to the next part. A minus A transpose is a skew symmetric matrix. So to prove what A minus A transpose is skew symmetric, matrix. For this, let us consider this one as some other matrix D, and again for this I will be taking transpose on both the sides. So taking transpose on both the sides, then you will have D transpose is equal to A minus A transpose. Now whatever the property we have for addition, even for subtraction, if I write minus here, so then for subtraction also the transpose can take individual. When I write together, try to understand above sign plus with plus, then below sign minus with minus. Okay, so I can apply the same thing here. So I am going to have A transpose, then minus as it is, and here second matrix A transpose there. So A transpose the whole transpose, and again since A transpose the whole transpose, we know if you take transpose twice, I'll get the matrix A itself. Now if you compare this with this equation, which I will take as 2, see carefully, here sign of A is positive and A transpose sign is what? Negative. But here A transpose sign is what? Positive, and A sign is negative. So only the signs are different. So what I will do, I will take minus common here. If I take minus common, minus into minus is plus A. Okay, minus into plus is minus. Now you see carefully this part, only this part. So this is exactly same as this. So I will take as D from equation number 2. Minus is there, so minus D10 is equal to D transpose. So this I have proved that it is a skew symmetric matrix, and I got this one from equation number 2. Now I can conclude that therefore D is equal to A minus A transpose is a skew symmetric matrix. So with this we have completed this problem. Kindly, it's a 5-marker question, and question number 40 here. Question says if matrix A is equal to 1 2 minus 3 5 0 2 1 minus 1 1, matrix B is 3 minus 1 2 4 2 5 2 0 3, and matrix C is equal to 4 1 2 0 3 2 1 minus 2 3, then we have to compute A plus B and B minus C. Also verify that A plus B minus C is equal to A plus B minus C. Okay, so this we have to verify. And again, before we just go ahead with this solution, but if you just observe here, this is actually associative property under addition. I can just say this is negative C matrix. Now only if I just see if addition is defined, without solving also we can say it will be true only, because it's a property, and for property to be true, only that particular operation should be defined. So you can see this is 3 cross 3, 3 cross 3, 3 cross 3. So orders are same. So surely addition is defined, subtraction is defined. So surely this property will be true. But since we are writing PU board exam, so we have to write all the steps and we have to verify it. Okay. So I just said this one with respect to MCQ. Okay. So coming to the solution of this, A plus B I want. First find A plus B. What is matrix A? Let us copy from here. 1, 2, minus 3, then 5, 0, 2, then 1, minus 1, 1, plus matrix B. Matrix B is here. 3, minus 1, 2, then 4, 2, 5, 2, 0, 3. Now we want to add the matrices. The corresponding element should be added. So let us add. So plus is there. So 1 plus 3 will be 4. 2 minus 1. Signs are different. We have subtract. 2 minus 1 is 1. 2 is larger compared to 1. So sign will be plus. Minus 3 plus 2 will be minus 1, as coming to 3 and minus 3 and 2. So just talk about the number. 3 is larger than 2. So sign is negative. So minus sign there. Then 5 plus 4. Signs are same. Add 9. 0 plus 2 will be 2. 2 plus 5. Signs are same. Add 7. 1 plus 2 will be 3. Minus 1 plus 0 will be minus 1. And 1 plus 3 will be 4. This is, let us extend a bit. So we have got this as equation number 1. We have just now completed A plus B. Now next thing is I want B minus C. Let us compute B minus C. So coming to matrix subtraction B minus C, the difference. Matrix B again from here, it is 3, minus 1, 2, then 4, 2, 5, 2, 0, 3. Minus matrix C. Matrix C is here 4, 1, 2, 0, 3, 2, 1, minus 2, 3. Now we want to subtract both the matrix. So see, as I said before also, that whenever negative is there, I have seen majority of the time student, when they want to subtract, no, they'll forget this sign. In place of saying 3 minus 4 is minus 1, they just go 3 plus 4 as 7. So to avoid this error, what I prefer, let us first multiply negative in. So first I will recopy the first matrix. So plus, this minus I can take in. So minus into plus will be minus 4. Minus into 1 will be minus 1. Then here, for all the negative sign is multiplied. Minus into plus 0 will be just 0 I can write. Because for 0 whether it plus sign or minus sign doesn't bother. Okay. Minus into plus is minus 3. Then minus 2. Minus 1, 2 and minus 3. So now we have to just subtract these two matrices. When I'm going to subtract these two matrices, means depending on the sign. So as per this addition. But when we go for element by element, as per school days, if signs are same, add, signs are different, subtract, and sign of the resultant will be of the number which has got, which is larger of both, So 3 minus 4 is 1, 4 is larger here, so sign is minus. So we have finished with 3 and minus 4, then minus 1, signs are same, add, minus 2, then 2 minus 2, signs are different, so subtract. 4 plus 0 will be 4. 2 minus 3 will be minus 1, because in this 2 signs are different, so subtraction. 3 is the largest number, so sign is minus, so minus. 5 minus 2 will be 3. 5 is larger, so plus sign. 2 minus 1 will be 1. 0 plus 2 will be 2. 3 minus 3 will be 0. So this will be matrix B minus C. So we have finished with A plus B and B minus C. Now we have to verify this. We have to add B minus C with the matrix A. This I will take as equation number 2. So let us go for this. A plus of B minus C. So what is matrix A? It is here. Let us recopy 1, 2, minus 3, 5, 0, 2. Then 1, minus 1, 1, plus B minus C. Yeah, coming to B minus C, this is the matrix. Minus 1, minus 2, 0, 4, minus 1, 3, 1, 2, 0. Now let us simplify this. Again, so let us, now I hope I can just complete without much reasoning. 1 minus 1 will be 0, 2 minus 2 will be again 0, minus 3 plus 0 will be minus 3, then 5 plus 4 will be 9, 0 minus 1 is minus 1, 2 plus 3 is 5, 1 plus 1 is 2, minus 1 plus 2 is 1, 1 plus 0 is 1. A plus B minus C. This is the equation number 3. Now I want A plus B minus C. Let us get that also. A plus B minus C. What is A plus B? Let us get it. Already we have got actually. Yeah, here it is. I'm just going to copy this. That is 4, 1 minus 1. Followed by 9, 2, 7. Lastly 3 minus 1, 4. Minus matrix C. It is here. 4, 1, 2. 0, 3, 2. 1 minus 2, 3. So I have to perform first subtraction. So let us take minus in. First we'll copy the first matrix as it is. That is 4, 1 minus 1, 9, 2, 7, 3 minus 1, 4. Plus here, then this negative in, minus 2 plus is minus 4, then minus 1, minus 2, then minus 0 here, then minus 3, minus 2, minus 2 plus is minus 1, minus 2 minus is plus 2, minus 2 plus is minus 3. Now I'm going to just simplify. Now when I want to simplify, as you know, corresponding element we have to add or subtract depending on the sign, same or different. 4 minus 4, you can see it is 0. Then 1 minus 1 will be 0. Minus 1 minus 2 will be minus 3. Then 9 plus 0 is 9. 2 minus 3 will be minus 1 because signs are opposite. So 2 minus 3 I have to subtract. It is 1. 3 is largest number, so minus 1. 7 minus 2 will be 5. Then 3 minus 1 will be 2. Minus 1 plus 2 will be 1. 4 minus 3 will be 1. So this is my equation number 4. So now you compare both equation number 3 and 4. This is my equation number 3, the left hand side of what we have to verify, and this is my equation number 4, the right hand side of what is given. So you can just see, when do we say two matrices are equal? Order and the corresponding element should be same. Yeah, order is 3 by 3, here also 3 by 3, and you see the corresponding element 0, 0, minus 3, 9, minus 1, 5, 2, 1 here. Therefore, from equation number 3 and 4, we can conclude that A plus B minus C is equal to A plus B minus C. So I think the marks allotment should be like this: finding A plus B 1 mark, B minus C 1 mark, then getting this one, and again this one, and final the conclusion. So with this model paper 2 we have completed with respect to matrices. Let us move on to model paper number 3. Question says, from 1 marker, multiple choice question: if a matrix has 13 elements, then total number of the possible different orders matrices which we can have. Options are 1, 2, 3 and 4. See, don't forget, when we discuss order, we discuss that order nothing but number of rows and number of column of the given matrix. If we multiply the order, we can get number of elements. So here in the question they are given that the matrix has 13 elements. So better try to find the factors, because the factors of 13 will give you the order. So 13 being a prime number, it is a number. What is prime number? First of all, a number greater than 1 which is divisible by 1 and itself. First it should be greater than 1. Yeah, it is more than 1. And it should be divisible by 1 and itself. So this number 1 into 13 is 13. It is by 1 as well as 13. So 13 into 1. Other than this, there are no factors for 13. So because of this, I have ordered to be 1 cross 13, nothing but 1 row and 13 columns. And because of this factor, I have 13 cross 1, nothing but 13 rows and 1 column. Totally, how many such matrices possible? 2 matrices. So only 2 such matrices possible. So option B will be correct. Now let us move on to this. Question says 3 marker from part C. For the matrix A 1, 5, 6, 7, we have to verify A plus A transpose symmetric matrix and A minus A transpose is skew symmetric matrix. Theorem number 1 already in our matrices concept we have proved. Now we are going to verify. See, as soon as it is square matrix, no, obviously addition of A and its transpose will be symmetric. A and minus means A and A transpose subtraction will be skew symmetric. That is obvious from the theorem. Now we are going to verify this. So coming to the solution part, matrix let us copy once. That is 1, 5, 6, 7. Then coming to transpose of this 1, 5 and here 6, 7. So this is my first row, change to first column. This is the second row, change to second column. Now we want to add. First part we are answering. When I want to add, we know how to add 2 matrices. First I substitute 1, 5, 6, 7 plus 1, 6, 5, 7. Now how are we going to add? Corresponding element we are going to add. So 1 plus 1 is 2, 5 plus 6 is 11, 6 plus 5 is 11, 7 plus 7 is 14. This is A plus A transpose. Now I have to verify that it is symmetric. So I will assume this as some matrix C for simplicity. Now if I take the transpose of this matrix, this is my first row, that will change to first column. This is my second row, it will change to second column. And I have got the same back. And this is what? Matrix C only. So I have got C transpose is equal to C. Therefore C, what is C? A plus A transpose is what? Symmetric matrix. This part is done. Now I have to go to the second part. Let us take it here. One second part to be completed. I have to comment, means I have to get that A minus A transpose skew symmetric. A and A transpose already there. So let us find the difference. So what is matrix A? 1, 5, 6, 7. And A transpose is 1, 6, 5, 7. When you are going to subtract, we know, as I said so many times, let us take negative in to avoid that error which I have seen from the student. So minus to plus will be minus 1, minus to plus will be minus 6, minus 5, minus 7. So now let us simplify. 1 minus 1, 0. 5 minus 6 is minus 1. 6 minus 5 is 1. 7 minus 7 is 0. Now I have to check whether it is skew symmetric or not. So for that I am going to go with the definition. So I will assume this has some matrix D. So throughout it is D. So now if I take transpose on this, so this is my first row, will change to the first column. 0 minus 1, and this is the second row, will change to the second column. We know for skew symmetric we should have A transpose is equal to minus A. So if you just see carefully, is this 2 matrix same? You see signs are not matching. So if I take minus sign out, for 0 no need to bother about the sign, but minus into plus will be minus 1, minus into minus will be plus. I said for 0 no need, because either write minus 0 here or plus 0 doesn't make any difference there. So now this part, if you observe, it is same as this. So it is matrix D, but negative sign is there. So D10 as it is equal to left hand side is D transpose. This obeys the definition of skew symmetric matrix. Therefore I can comment D is equal to what? A minus A transpose is skew symmetric. Skew symmetric matrix. Yes, so with this we have completed the 3-marker question on matrices. My dear students, we are to the last problem of the model paper, and it's a 5-marker question, part D, model paper number 3. For the matrices, the question is saying for the matrices A given here and B, we have to verify A into B whole transpose is B transpose into A transpose. It is one of the property of transpose of a matrix, and it is given as a 5-marker question. And let us try to go ahead, and this will be bit tricky because it's a rectangular matrix. For square matrix, whenever student multiply two matrices which are square matrix, even for rectangle, if it is of not this form, they are comfortable. But as soon as this many student does the error. Let us try to sort it out. First, I have to get A into B, then transpose. First, let us write down A. It is matrix -2, 4, 5. Then comes matrix B, 1, 3, -6. Let us recall the concept first. To perform matrix multiplication, number of column of the first matrix and number of row of the second matrix should be same. First, check that. How many rows? 3 rows. That is first row here, second row, third row, and this is one column. Here, how many rows? Only one row. And how many columns? 1, 2, 3. So totally 3 columns we have. So since 1 is equal to 1, number of column of the first matrix, number of row of the second matrix, both are same. So I can perform matrix multiplication. But this is also saying that after you multiply, the order of the obtained matrix should be 3 cross 3. So if you do like this, you'll never go wrong. Okay. And now how to perform? Recall row and column. As soon as you multiply, corresponding element first we have to multiply, and then we have to simplify. As soon as you finish a column, we have to shift to the next column. Okay, no? Sorry. Now, let us perform. This is my first row, first column. -2 into 1 is -2. As soon as I have performed, do we have any more column in the, any more element in the first column? No. Then I have to shift to the next column. When I'm shifting, I have to give a space. And row I'm not going to change till I won't complete with all the columns. So now -2 into 3 is -6. Do we have any more columns element here? No. So now we'll shift to the third column. Row remains same. Minus into minus is plus. 2 6 are 12. Do we have any more column? No. Close the matrix. So again I repeat. -2 into 1 -2. Again with the same row. Next column element. -2 into 3 is -6. Last is the third column element. -2 into minus will be minus to minus will be plus. 2 6 are 12. Since we are finished with all the columns, now we'll shift to the second row. 4 into 1. So again, second row with first column will be 4. 4 into 3 is 12. Again, we are going to a new column. Give a space. 4 into -6 is -24. We are finished with all the column. Now move on to the third row. 5 into 1 is 5. Now moving on to the second column. 5 into 3 is 15. Then 5 into -6 is -30. This is A into B. Now see, we want transpose. And before we go ahead, see the order. 3 rows we have. And 1, 2, 3. 3 column we have. That's what I was saying. Yes, we are correct. Now moving on to A into B, the whole transpose. Let us perform A into B, the whole transpose. Change row to column and column to row. This is my first row. -2, -6 plus 12 will be here. Then 4, 12 and -24. 4, 12, -24. Lastly, 5, 15, -30. Again it is 3 by 3, and I will take this as equation number 1. Now I want B transpose into A transpose. Now let us find first B transpose. How to get B transpose? Change row to column and column to row. This is first row, change to first column. 1, 3, -6. Next I want A transpose. Yeah, it's here. So coming to that, A transpose is the first column, only one column it is. So change to row. So -2, 4 and 5. Now we'll perform this multiplication, that is B transpose into A transpose. We are taking the right hand side now. And here we have just taken left hand side. Now coming to this B transpose, it is here 1, 3, minus 6, and here minus 2, 4, 5. I have seen many times the student, no, when we ask this, no, when writing, they write this matrix first, even though they write this perfectly, but while substitution, they first write this matrix A transpose, then B transpose. Don't forget, already in the concept we have discussed, commutative did not be true in matrix multiplication. So don't change the order, follow the question strictly, okay? Now, first row, first column, 1 into minus 2, minus 2. Do we have any more column entries? No. So jump to the second column. When you go to the second column, I have to give a space. And I'm not going to leave first row till I won't complete all the columns. 1 into 4, 4. Then 1 into 5, 5. Okay, now moving on to this second row. 3 into minus 2, minus 6. 3 into 4 will be 12. 3 into 5, the third column will be 15. Then minus 6 into minus 2 will be plus 12. Minus 6 into 4 is minus 24. Minus 6 into 5 will be minus 30. And this is of order 3 by 3, equation number 2. So left hand side as it is. Now compare, are they same? Minus 2, 4, 5, yes. Minus 6, 12, 15, yes. 12 minus 24 and minus 30. Therefore, from equation number 1 and 2, I can conclude A into B whole transpose is equal to B transpose into A transpose. Okay. So with this, we have finished all the model paper questions on matrices. I just want to comment here that when we are having a problem on 5 marker, especially to prove that problem, sometimes no, I have seen students, they may not have got, for example here minus 24 is there, here also minus 24, they might have not got, they might have got some different answer. So when you have got some different answer, surely you have did some error. You can cross check in place of manipulating. See, the person who is evaluating a paper is more experienced than you. So you people kindly don't think no, you are smarter in this. The person who is correcting, no, he is the smarter. Okay, so kindly believe in hard work. All the very best, study well, do well. With respect to matrices, the model paper questions, all the 3 we have covered as issued by Karnataka School Examination and Assessment Board. Okay, thank you very much. Dear students, having completed all the problems from the model question papers from the chapter matrices, now it is time for the assignments. Assignments are mandatory. Assignments are mandatory. If at all you are doing the assignment, only then it's an assurance that you are the perfect. So the assignments I have taken from NCERT text. I have mentioned the page number for you. Okay, and I'll also try to provide a soft copy of the same. I will just share the link where you can download the textbook. Okay. So from page number 54, this is a 5 marker question. So as I know you solve, you can complete the solution because an example problem. This is also a 5 marker question. Let I just spend some time on this because here you have got A is equal to 3 by 3 matrices. Then show that A cube minus 23A minus 40I is equal to 0. I have spoken already that A cube means not cubing throughout each term. No. You are not going to cube each and every term. You have to multiply matrices A 3 times. So let I just teach you once how to get A square. From there you are going to proceed. See the solution part for this. Just I will find A cube means A square for you. A square means multiplying A twice. Okay. So what is A? This element, right? This matrix element we can write. I just thought let I just teach you once how to find A square. It should not happen that you have squared each and every term. A square means multiplying A twice. So now how are you going to multiply 2 matrices? It is row versus column. Same logic. Let's multiply. 1 into 1 is 1. Then 2 into plus 3 will be plus 6. Then 3 into plus 4 will be 12. As soon as you have finished the first column, you have to go to the second column. When you go for the second column, you will give a space. Now again with the first row, multiply second column element. 1 into plus 2 is plus 2. Then 2 into minus 2 will be minus 4. Next 3 into 2 will be 6, that is plus 6. I have completed the second column. Now I will go for the third column. When I go for the third column, again give a space. Next 1 into 3 will be 3. Then 2 into 1 will be plus 2. Then 3 into 1 will be plus 3. Now you can see we have finished the third column. So there are no more columns. So I can close the bracket for the matrices. Let us draw a line, a boundary. Now having completed first row, now go for the second row. Now when I go for second row, same, 3 into 1, 3, minus 2 into 3 will be minus 6, 1 into 4 will be plus 4. Again you are going to go for a new column, keeping the same second row. Okay, see, there should not be any confusion also. For example, you see, no, I want to obtain the element present here, correct? Now this element, whatever I should get, present in which particular row and column? This is there in second row and second column. I repeat, this particular location is there in which row? Second row and second column. So I have to multiply second row of the first matrix by second column of the second matrix. Simple. So see, 3 into 2, 6, minus 2 into minus 2, plus 4, then 1 into plus 2, plus 2. I have finished. Now I will go for the next column because I have finished the second column. When I go for the next column here, the entry should be here. So again you see, this entry is second row, third column. Yeah, second row, third column. 3 into 3, 9. Minus 2 into 1 is minus 2. Then 1 into 1 is plus 1. Now moving on to the third row. 4 into 1 is 4. Like just write it a bit below. 4. Then plus 2 into 3 will be plus 6. Then 1 into plus 4 is plus 4. Now go to the second column. 4. See, I have to enter this, so I have to go for this second column. Okay. 4 into 2, 8. 2 into minus 2, minus 4. 1 into plus 2 is plus 2. Now this last entry, and this is present in third row, you can see, and third column. So come here, third row, third column. 4 into 3, 12. Then 2 into 1 will be plus 2. Lastly, 1 into 1 will be plus 1. Let's create some more space. Plus 1. Okay. So we have finished all the entries. Now let us simplify them. So 1 plus 6 plus 12 will be 19. Then 2 minus 4 will be minus 2. Minus 2 plus 6 will be 4. 3 plus 2 will be 5. 5 plus 3, 6, 7, 8. 3 minus 6 is minus 3. Minus 3 plus 4 will be 1. 6 plus 4 is 10. 10 plus 2 will be 12. Then 9. Okay, minus 2 plus 1 will be minus 1. Minus 1 plus 9 will be 8. Then this will be 10 plus 4, 14. 8 minus 4 will be, okay, 4 plus 2 will be 6. 12 plus 2 plus 1 will be 15. So this is your A square. Similarly, next you have to find A cube, that you are going to do yourself. What is A cube? See carefully, it is A squared into A. So already you have found A square. For this, multiply again this. Some will ask, sir, can't I write like this? First A then A square. No problem. Both will be same. Since both are same matrices, it is same matrices A. Here commutative will go ahead. So other than diagonal matrix, if it is the same matrix, commutative will go. Means it will hold good. I mean to say commutative will hold good. Okay. Now, this is again a 5 marker question. Okay, same type we have discussed in model paper question. 5 marker again. This I have again. This is also a 5 marker. This all are properties. It will be surely true. Be careful. Given A transpose here and B. So you want A plus B. First you have to take transpose again. Don't forget here when you are going to solve the problem, you are going to use the property that A transpose, the whole transpose what? A itself. So for this particular matrix, you are going to take the transpose again and then you are going to get A, and then you are going to perform the operation. And this one, as expected, sum of symmetric and skew symmetric are given 2 problem, which is a each 3 mark question. Together it's not 3 marks, it's each 3 marker. So I hope you will utilize this effectively and make sure do the assignment. With this chapter, matrices come to an end, and all the very best. Do well. Yeah. One more thing, my dear students, before I just wind up this chapter, I will be trying to share a link where you are going to have access for question bank, which is a question. I repeat, question bank which is issued by PU board. In that we have 1 marker question, 2, 3, 4, 5, 6 chapter wise. So I will also give the link for the same. You can download, and as and how you are completing the problem, make sure try to solve 1 marker question. And in case you have got any doubts, one means the entire question bank, you can just go ahead chapter wise. In case any doubt, you can mention the page number and the problem number along with the chapter name. Surely I will schedule one class depending on the comments given by you to have one session on this as well. So go chapter wise. Okay, so whatever the chapter already have finished, for example, linear programming problems is done, application of integrals is done. Now presently we are doing matrices. Okay, so but for linear programming problems and application of integrals, as per the blueprint given by the PU board, there are no 1 marker. Each linear programming problems is only for only 1 question will come for 6 mark, and then other chapter is application of integrals, only 1 question will come for 5 marks. So okay, for this there is no need to worry, but from here it is okay 1 marker. Don't forget 80 on 80 you can miss only if you are not able to get 20 on 20, first 20 1 marker question, that is MCQ and fill in the blanks. Okay, so with this I'm going to wind up this session. All the very best. Do well. Make sure study well, and do share, like and subscribe. All the very best. Study well. God bless you all.